Did you ever want to access one of these new hot AI tools from Java? Rather than using Python or some node interface or something like that, you're working in the Java world, presumably on the server side, and you'd like to incorporate ChatGPT into your system. That's what we're going to do in this video. Now I'm starting here at the API reference for the OpenAPI platform. So I'm at platform.openapi.com inside the docs at the API reference. Now, the first thing you have to do in order to access a service like this is make sure that what they provide is a RESTful web service. And this does. They do mention Python, as so many of them do. But then as soon as they mention Node, you're like, oh, wait a minute. They've got a REST interface that supports GET and POST requests, things like that. Now, step one is to register and get a key, because they do charge you for this, even though the charges are pretty small, I gotta say. In another video in this series, I showed how to get a key and to run requests and how low the prices really are. So to do the authentication, once you get an API key, then you have to set a header on your request with the key being authorization and the value being the bearer and the OpenAPI key that you acquired. So here's an example of a curl request that lists the various models built into ChatGPT, which has the authorization header in it. This one also shows an organization, but that's optional. And if we take a look at this, then in a different video in this series, I went through that process, and let me just show you the results. So this OpenAPI or OpenAI class has the base URL and the key, which I saved as an environment variable on my system. That way I could retrieve it programmatically. I don't have to worry about checking it into a GitHub repository or anything like that. I'm also later going to use Google's Gson to parse the resulting JSON data, both if to generate it if I'm sending it and to parse it when it's coming back into Java records. This method called list models creates a new HTTP client, which was an API added in Java 11. And then for the request, I make a new builder that's going to go to the models URL. There's the authorization header. I also specify the content type as JSON data, not strictly required, but generally a good idea. This is going to be a GET request, and I build it. In the try-catch block, I just call send on the client using the request and ask for a string back. When that comes back, I extract the body from it, and I'm using Gson to convert it into this list of models that I showed in the other video. To show you this working, I have a test class here called OpenAI Test. And what I'm going to do let's look at the second test first. This is the one that's going to call list models, get the data back, turn it into a stream, sort them by their created date, and then print them out. And if I run this, you'll see that there's quite a number of models available. There's a whole bunch. I'm really not interested in that for this video. Instead, what I want are the models that have GPT in them. So here I'm going to call it again, map them to their IDs. That's where the model value is. Filter them by IDs that contain GPT, convert it into a list, make some assertions about it, and then print it. And here's the model list that comes out. These are the 1, 2, 3, 4, 5 models that all start with the letters GPT. I don't have GPT-4 access yet in the API. I'm on the waiting list. Hopefully I'll get it soon, but it won't affect what we're doing in this exercise. Okay, now let's see how to interact with ChatGPT. In this section of the API reference, they talk about how to make a request with the API key, but this time the endpoint is chat completions rather than the models. Also, we need to pass a body into the request. We have to pass a JSON object that has a model, says which model we're using, messages, which looks like some kind of array of role and content combinations, and then temperature as well. Temperature is a measure of the randomness that is used by the engine when coming up with a solution. Well, just to see that we can get there and get a response back, let's do this with straight text and For that, we can use a relatively recent Java feature called text blocks, our multi-line strings. So let's take a look. Back in our class here, I can reuse a lot of this, but not everything. So I'm going to start off by saying, let's do public and return a string called access GPT chat, just to see that we can get there again. And I'm going to take everything from here, but I'm going to modify it. So let me copy that and paste it here. And I do make a client. I do make the builder. Again, we saw that the URL is a bit different. It's /chat/completions this time. I do have the same authorization key and the same content type, but this time it's going to be a post request, and a post request takes what they call a body publisher. Okay, so what's in here? We pass in the model saying it's GPT 3.5 Turbo. We pass in messages, which is the array of role and content. Role is user. We'll talk about the values for that later. And content is say this is a test. Again, we went with the default temperature here. This time when we do our send, we do want the response back as a string, but we're not going to parse it yet. Instead, we'll just simply return response.body, the body out of the response. And there we go. Now we're all set to access this and take a look and make sure that we get the response back we're expecting. Now this is the test I want to run to make sure this is all working. I simply added this to the same test class. I call that method, get back the string response and print it. I'm just going to assert that inside that response, there's the string, this is a test, with ignoring the case just in case I have a case sensitivity problem. Let me run this. And you can see that it worked. I got back this JSON block that said, yes, we access chat completion. This is the model we're using, ChatGPT or GPT 3.5 Turbo June 13th version. Here's the content we want. Now you see how the structure is set up in this response? When we parse this, we're going to have to get down to choices, first element in the array, which is this object, access the message, and inside the message, there's the response we want. And the role that's provided by ChatGPT is the assistant role. It also tells us how many tokens we used up in the input and output. And believe me, that's hundredths of a cent. That's really very, very low in the amount of money. Okay, so far so good. Now let's move to an actual model. To keep things as simple as possible at first, I'm going to add records to represent this structure, both the input and the output. And I'm going to add them directly inside the class I'm working with. And I'm going to add them in a nested way that matches the JSON structure. This is a very easy thing to do, but to make it even simpler, I'm not going to do it. I'm going to have the AI assistant inside IntelliJ IDEA do it for me. Now, if you don't have the AI assistant, that's fine. You can go to ChatGPT and ask it to do it. But I happen to have that available. So what I'm going to do here is in the AI assistant, I'm going to say, please provide Java records to match this JSON structure. Quote, 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 and then I'll paste in that message part. Now, this is a really simple one. I could do this by hand, but what the heck, I might as well ask it. Here's the response that came back. It's typical of GPT in that the training ended in summer of 2021, and Java 17, where records became final, didn't come out until September of that year. So it's still talking about Java 16 onwards. That's about all it knows, but it'll be enough for what we're doing. So they said, let's make a record called model record, which has the model in it and the list of message records and a double temperature. And let's make a record called message record, which has the role and the content. I don't know that I want exactly those names, but I like the idea. So let me put my cursor inside the class, and I'll hit this little button, which will insert those snippets at the caret. Oh, don't need the import statement. and I'm going to change message record to just message. And for the input, because I know this is the actual request that I'm sending, the body of the request, I'm going to change the name of this one to chat request. So a chat request has a string, the model we're using, a list of messages, and a double for the temperature. And we get back we're also providing a message in the form of role and content. And we'll talk about the role later. Okay, let me do the same thing for the output. Okay, here's what I submitted this time. Please convert this JSON structure to Java records. And again, you can see there's my output coming back. So it gave us a main record. That's going to be our chat response as opposed to the chat request. Has an ID, this string object, which is always the same in every one. So we don't even really need that. The created timestamp, a string to say which model we're using. The usage is going to be a record that's going to have the various tokens in it, and then a list of choices. And here is the usage with the prompt tokens, the completion tokens, the total tokens. The choices has a message in it, but that's the same message from before. The finish reason and an index, and then here's the message. So we don't need all of this now, because first of all, we already have the message. Secondly, I know what I'm going to call these. So actually, let me copy these. And I'll put them in the class, and then I'll restructure it. And I'll be right back with you in a second. Here's the list of records. And as I mentioned earlier, I'm going to nest them where I can just to make it look like the JSON structure. That makes it a lot easier for viewers to interpret what they're seeing, to understand it. Also, one of the nice things about records is they're nestable practically everywhere. So I just put them in as a way to make it easy for us to read. I changed the return class to be called chat response. This will be the record that comes back. The other thing that by the way, I changed usage record to usage, I changed choice record to choice, and I'm reusing the message that we sent. But I have to make one other interesting change. When I parse this with Google's Gson, you notice I put in that field naming policy, converting snake case to camel case. So I'm going to change prompt underscore tokens here to camel case. Same thing with completion tokens and total tokens and the finish reason. And there we have it. We have a message to send as part of a request. We have a response here. And now all I want to do is parse this. Now we already have an existing test that sends a text block that isn't parsed yet, but okay, we'll just use the text block. And at the moment, I'm returning a string down here at the bottom. Let's see if I can now parse that instead. So instead of returning response.body, I'm going to return json.fromJSON. There's the body, and the class will be a chat response class. Now I could dig into the rest. That's what GitHub Copilot is suggesting, because my return type at the moment is still string. It's saying you can go all the way down and just get the content if you want. I think I'll return the actual chat response and just update my test to work with that. So if I go over to the test now, this is no longer a string. It's a chat response, which I could print, and then I could go response dot choices dot get the first one dot message dot content. And now let's take a look. And now you can see the toString method on the records is showing up here. So there's the ID, there's the object, which I don't care about. There's the created timestamp. There's the model, same one as before. Here's my usage tokens. Here's my choices. That has a choice, that has a message. So see, I went down to the choices. I got the first one. I got the message inside, and there's the role. And here finally is the content I wanted, and that's the output. And this finished, and everything's working so far. Looks good. Now let's fix the input. So before, I was passing in a JSON object with this model in it, and text blocks are great for that. but what the heck, I might as well create the message as I need and then convert it from the record to JSON this time. So let me add a method to do that. So here I've created a method called create chat request that takes the string, the prompt that I want to send to ChatGPT. I specify the model. I hard-coded that in at the moment. We could always make that more flexible later. And I put in a list of new message, and it's a user message with that prompt in it, and left the temperature there. Obviously, I could add additional arguments to this method or add some overloads where I could specify the model, I could change the temperature, whatever we like. We'll get into some of that. So now down here, instead of putting in my hard-coded text block, instead I will put in Gson to JSON, creating that chat request with, say, this is a test. And now let me run the test again and see if it passes. And it did. Everything came through, everything got passed correctly, and the content is, this is a test. So all we had to do was this much, and honestly, you can kind of go from here. But I'd like to generalize this a little bit. So let me make a couple changes to make this a better design project. Like, I'm going to take these records and I'm going to put them in a file, I'm going to move them over somewhere a little bit better. Also, I'd like to see if I could eliminate some code duplication here. Okay, so as the first step, I extracted the records from being inner records here to separate records in their own individual files. So here's message, for example. Here's the chat request with the model and the messages, list of messages and the temperature. And here's the response with the same nesting that I was using before. I made them all public because I'm not trying to hide anything. I want to be able to use all these. I couldn't put the message in here, obviously, because I needed it elsewhere. But in general, it doesn't hurt to combine them this way to make it easier to read. Let me run the test again and see that everything's still passing. And it is. We're good. So everything is getting back the same answer as before. The content is working. Let me show you one of the really neat features of AI Assistant. Here's my AI Assistant, and I used it earlier to come up with the records based on the JSON structure. Well, one of the other nice features of this is if I go into the commit window, the commit view in IntelliJ, then it says these are all the files that have been changed. You can see them all there. I will select that whole thing, and there's a little button down here that says Generate Commit Message with AI Assistant. And I love this. Watch this. So it added a one-line summary, added chat request, message, and chat response records for GPT-3 interaction, and then it says in more detail everything that was modified, and I will commit all those changes. And now I have a decent commit message. I think that's wonderful. The one-liner is easy to read. The details are excellent if I'm trying to figure out what changed in each commit. And I don't like writing commit messages, so that's very helpful. Another thing I can do now is say, let me select the entire class and right-click. And under the AI Actions menu is Suggest Refactoring. Let's take a look at the results. It basically says, your code is well structured and clean, thank you. However, the HTTP client is instantiated twice, and yeah, I noticed that. That really isn't necessary. And potentially more times as you add more methods. Instead, you have HTTP client in a field in the class, which gets, you can have it in a field which gets instantiated once. I agree with that too. The way how to handle an exception also might be improved. The current implementation throws runtime exceptions that you do not have any specific message for. But anyway, it's better to have a more descriptive error message to make debugging easier. Well, I'll have to think about that. So what I notice up here is still got the Gson exactly the same way, made the HTTP client an attribute. That certainly seems reasonable. They put in a send request here that calls send only and has the exception handling. They put in get request and post request for the HTTP verbs, where you specify the part of the URL that is the target. Now, I don't know if I need that because in the GPT model, the only request that supports GET, the only endpoint that supports GET is that list models one. And if I'm going to interact with post, or with chat rather, they're all going to be like that. So I guess I could do this, but I don't know that I need it. But fine, I could also put in a string with the body. Again, I'm not sure I want to put in the string. It might be worth it to put in the request object, the chat request, and let it go ahead and use Gson to parse it. But this method's simple enough. So at any rate, these the rest of it is just using those methods. So list models just sends the request, get a request to this URL and send a request. And the access chat does a create a chat request and post it and get back a response and format it. Not bad. In fact, what I think I'll do is I will select the entire class here and I will go ahead and overwrite it with this. It's a little brave, but okay. And see if it messed up my formatting. I'd rather have a little bit different formatting, I think, here. Just easier for me to follow. And I'll organize imports. And again, it's already pointing out, hey, you've only got one URL here. Do you want to inline that? And if I say yes, then it did take it out of the variable. And I think that's reasonable here. The GET request does the same thing. I'll let it do that as well. So again, I'm using the functionality of the API, of the IDE rather, to improve all that. And then let me run my test again, make sure I haven't broken anything. And that's passing and we're good. Finally, let me commit all the changes. Refactor HttpClient usage and OpenAI module, and that will improve readability and testability, getting rid of redundant code. Yeah. Commit. Okay. I think that's enough for this particular video. In the next video, what I'm going to do is use this API to do something a bit more interesting. What I want to do now is I want to provide a list of topics and have ChatGPT generate a multiple choice quiz from that list of topics using Java parallel streams and maybe even asynchronous processing, so that, and write all the results to a file, just so I could manually generate information and incorporate GPT into my Java system. That's the basic idea. So that'll come in the next video. Now there should be a link here to the other video in this playlist, as well as the playlist itself and a subscribe button. So hopefully I'll see you in the next video as well. Take care.